Hello, I'm Joshua Jodesty. Today I'll be presenting CATS. It's an acronym for Content-Addressable Transformers, and it's a reference implementation for a POC that I'm working on. So CATS is a data product interoperability framework that enables you to swap data processing frameworks like Spark, DAS, and other frameworks like Function as a Service, for example. The workloads could be on multi-cloud services, and they provide data provenance. It allows multidisciplinary teams to work on data products using the entire cloud service model. So that's software as a service on top of platform as a service on top of infrastructure as a service. And it processes polyglot data results. They could be operational and analytical. On the right-hand side in this shape right here, the analytical data output would be the result data on the analytical data plane. And these bill of materials, which is a supply chain term I'm using, has the operational data, which is a data provenance record of IPFS CIDs, similar to Git version history. So teams could use the CIDs to verify data processing during data discovery, as well as transport and re-execute processes on a network of connected CATs. Okay. So why are they useful? Okay. They increase scaling and decentralized operations. So they parallelize operation and maintenance between multidisciplinary teams within multiple business organizations, or just organizations across business domains, right? And the domains would be cross-functional, dependent on the team. And I'll talk about that in the next slide. It increases operational efficiency. It decentralizes product ownership in such a way that the business domains, it enables a customer-centric approach to implementing products with tighter feedback loops for teams. I think I should, let me just, this is an illustration of how this is Spotify. Okay, you can think of this as like a product like Spotify, but the product, each of these products is a business domain. So a CAT would be used, each of these products are a business domain. So each CAT would be kind of like a micro product that decentralizes a traditional product involving all of these domains. So the O's represent operational data, and the D's represent analytical data, and the arrows between them represent CATs connected to each other, right, on a network, okay? So in other words, it decentralizes a monolithic product by breaking it up into cross-functional micro products between organizations or on a network of peers. So if CATs were deployed virtual machines as peers on this network, it will link these products implemented on existing cloud services like AWS together on this network. So why do CATs? Why do we use IPFS for this? So IPFS is a protocol, a peer-to-peer protocol for storing and retrieving files, right? So the technical term for what IPFS implements, which they're calling a CID, is a content-addressable storage. So it's a method for storing and retrieving location-agnostic URIs that are unique cryptographic hashes issued for unique files. So in other words, the contents of the file are the same, the hash will be the same unless otherwise, right? And to my knowledge, it's the only content-addressable storage protocol that I'm aware of that can be used for data verification and transport, which the location agnostic URIs could be collected into, I would say, a data provenance record. So essentially I'm using IPFS for data provenance, right? Because it could be stored and retrieved using URIs, but IPFS isn't storage, it's a protocol, so somebody would be responsible for storage themselves, okay? And I would say data verification is only guaranteed if the transformation or the data process is deterministic. So if you're using random number generators, use a seed. Otherwise, the hash will be the same. Won't be the same. Sorry. Okay. So I keep on saying this word data product, and I should define it. So it's a node on a mesh network that encapsulates the components that function as a service in a way that provides access to a domain's analytical data as a product. So these components are code, data, metadata, and infrastructure. Okay, and the use case would be a multidisciplinary team operating on a restricted domain as with restricted business domain, and that business domain would own the product. So an example would be like a data scientist or analyst using this data transformation interface to be deployed as software as a service with some interoperable processing framework like Spark as a part of a CAT process. So the processor would process data using Spark SQL or DataFrame API or something. Okay. And then there's a back-end engineer or machine learning engineer implementing a CAT application as software as a service for the data scientist deployed on, I don't know, a managed Kubernetes service, for example, as platform as a service right here. And then the infrastructure engineer would use Terraform or infrastructure as code. Okay, so it's kind of like data-driven design and development, similar to user-driven design and development. And a data scientist can act as a micro-product owner, which alleviates the traditional product owner's communication overhead due to user-driven development, so they can focus on user-driven design. So, like in this slide above here, okay, the analyst and the traditional product would be working closely together, right? And the analyst or the data scientist will inform the development of the product and the design of the product directly. So it puts them, it's like a communication improvement for data products. Okay. Right, so I'm using this term bill of materials. Okay. It's a data provenance record with IPFS CIDs. So yeah, because it can store and retrieve, and it's verifiable. So this BOM is the IO of CATs. So the transformer has a CID, or the, whatever the analyst is interfaced with has a CID. There's this concept of an invoice that I'm using, which is a content address data set. So it's a collection of IPFS CIDs and data partitions. And the demo's case would be Spark data partitions, which is being processed by Spark. Yeah. So yeah. So, and I should say, data provenance is just a type of data lineage with historical records containing metadata, describing the means of processing from source to destination. But IPFS provides the additional value of it being re-executable upon retrieval. So that's what I'm providing the CAT as input. Okay? So this is an example of a data pipeline that uses these cats as IO, and they're linked by this bill of materials URI. And mind, I should make a joke here. This is a supply chain. It's a data supply chain. Okay. So this is a data supply chain. Okay. So cat 0 would be the initial content address transformer that produces the initial bomb, which is called alpha. And the bomb it produces would be given to a cat, which produces a subsequent data provenance record, and so on and so on. And this is an example of a header record for the entire pipeline that contains sequences of these CIDs to re-execute the entire pipeline, which probably should be a part of each bomb. I'll consider that for the future. But you get the idea. So these records, once they're on the network, you're establishing a network, and the operational data URIs are used to retrieve them. So it's kind of cool. So, so CATS was designed with this principle. It's called an architectural quantum. It's a domain-driven design principle. It's the smallest unit of architecture that can independently. It's the smallest unit of architecture that can independently be deployed with high functional cohesion and includes the structural elements required for its function. Functional cohesion because they're close together. I took this from Savakdagani in this article, Data Mesh Principles and Logical Architecture, domain-driven design. So it enables data product implementation with a cat. Okay? So the action and control planes are orthogonal groupings of a node's I/O interface. Okay? So the action plane here is a collapsed plane of, let's say, the analytical data plane and the control plane in Kubernetes. So it's a collapsed plane. So it's a one-dimensional representation of a two-dimensional plane in multi-cloud or cloud. The control plane would be the I/O interface that networks the cats. So you're essentially connecting a cloud, a product built on the cloud service model to a peer-to-peer network. Right? So the plan and infrastructure are classifications of the node structural elements. I'll explain what a plan is in the future, but infrastructure is self-explanatory. Process and infra functions are classifications of the node's functional elements. The process would be the data transformation interface used by an analyst or a scientist or a data scientist. The infra function is a utility for the plan, which is a data transformation framework. And the process is performed by the data transformation framework to transform inputs into outputs in a way that adds value. So I already described this. Like I said, it's a one-dimensional the action plane is a one-dimensional representation of the operational and data planes of a centralized cloud service. So it's the analytical data plane. It's data I/O, and the control plane is decentralized peer-to-peer network. Okay? It's communication between cats using CIDs and governance and of the configuration and policies on data mesh. And I explained this plant. Like an example would be Spark DAS, function of the service, etc. Interoperable. Infrastructure as code would be infrastructure. Process is like a data transformation API, computational process, SQL, etc. And infra function is utilities. This is an example of how the components of this architectural quantum works. Okay, so you have a software factory that produces a cat processor that constructs function and structure, which were components in the previous design, in a way that function runs or executes on the structure. Structure being, I don't know, Kubernetes deployed on some managed Kubernetes service in AWS. Okay, and it makes these reports. Well, it configures and reports bombs. These are views of the bomb. It has the same CIDs that are in the bomb. It's just a different view. And once stored, can be retrieved and it's on the network. And these are the inputs. The function is a code, input data, structure is code. The factory uses that to produce the processor and then execute the processor. And then you have your analytical data on the right-hand side. Okay. Demo. Okay, right. So. All right, so the top half is the infrastructure, and I'm using Minikube right now. Okay, so the bottom half is just an activity diagram. So this is what I'll be demoing. The initial cat is creating the initial bomb, and the subsequent cat is processing data on network and producing a subsequent bomb for the cats. This is like an example of the transformation UI. It's SQL, Python data frame. Okay. Okay, so I'll just explain this. I should explain this before I demo it. All right. So this is an example of a cat's Kubernetes infrastructure as an execution environment that is instantiated on Minikube. Like I said earlier, it could have been EKS. It doesn't matter. So it's an infra function that uses kube control to create a service account for submitting Spark applications by the user, which would be the analyst or data scientist or whoever is doing data transformation or processing. Okay. Cluster role binding for namespaces, like, I don't know, the cluster role, cluster namespace on Kubernetes, secret for AWS, just secrets for access control on whatever cloud service platform you're using. So that's all here. And yeah, Spark is a Docker imaging tool. I made a custom image and put an IPFS client on the image. And I built the image with the tool. Okay. That's the first part. And I'm not demoing that part because every cat does the same thing or skips it over in Terraform. Okay. So that happens on top here in this section here. Okay. So this is an example of an initial cat, which I'm calling cat 0, using an infra function to execute a cat 0. So it builds the PyCat software into a package. It installs the package on the driver's virtual environment for PyCats. It zips the driver's virtual environment. It executes Spark submit and sends the virtual environment and cat application to worker nodes in a Spark cluster. So let me show you that. So I'm just executing the first cat. So I'm just walk you through this. So this is creating a virtual environment. Okay. Installing dependencies. Zipping it. Skip this. And the application that's running was sent to the application that's running was sent to containers it's sent to the Spark cluster in Kubernetes pods. So it's just distributed the application in virtual environment. Okay. The Kubernetes is setting up the infrastructure I explained above, and now Spark is running. It's going to take a while. Skip this. Show you the results. Yeah, I wanted to record this. I prefer to explain it ahead of time. I just showed you it worked. Okay, there's a lot going on. Pause. Okay. Okay, this is an example of the invoice that I was describing with a single partition. So it's just a data set with a CID, the partition itself, and some metadata. These are URIs for the IPFS client. They're just locations of the IPFS client. Okay? And this is the provenance record. Okay. So this hide part CIDs, this is a CID of a single partition. Okay. And this is the bomb CID. This is the URI in S3. But everything necessary to run the subsequent cat is here. Right? That's being produced. Once modified, okay? So I'll demo the next slide. Okay. Yeah. Okay, the only difference between this cat and the previous cat is now, given the bomb that I just showed you, which is this one, alpha bomb that was just produced, this cat is executing on network. So right now, the Kubernetes cluster, because I'm not using IPFS storage solution, I have a cache on the worker nodes of the Spark cluster that is IPFS clients. So I keep the cluster ephemeral until I get a storage solution for it. Okay. So all that's happening is the transformer CID. You get it from the IPFS cache and transfer it to the file system that the data processing framework is using, okay? Which is, in this case, a Spark, and that's S3. It could be HDFS, it doesn't matter. And I don't know how to, use those storage solutions with these frameworks yet, but we're working on it, okay? And then the transformation for the data process, I don't know, let's say tabular data structure manipulation, like let's say a Spark data frame. The transformation script, that's a better way of saying it. The transformation script is applied. Okay, the transformation is done. The data is, in this content address data set, is transferred to the file system. And yeah, it's content identified. The output is content identified. The bomb is generated. The invoice is generated, which is a content address data set, and you produce the second bomb. So I'll just prove that works and show you what's in it. Okay. So I don't have to go through the initial steps because the infrastructure already exists in Minikube. I should probably show you that. that's the original data set. This bottom half is like all of the information that changes, which is like IPFS clients, URIs. Yeah, that's the result data set right there. It's just an aggregate view. That's the original BOM from the previous cat that was produced by the previous cat. And this is a subsequent. And here's some metadata. And yeah, I just want to thank these people: David Sisson, Michael Zargum, Jeff Emmett, Jessica Zartler, Barada, and Nick Arnett. I wouldn't have been able to do this without them. Okay? And this is me. I've done a lot of things. Too many things. All right. And questions.
Basically, what for us really demonstrates location agnostic, uniquely identifiable. Basically, we have data processes that span multiple organizations, either within or between you can include which functions are you can check or log in their services, even though they were locked. Layer, we basically have to build that whole structure and uniquely address specific infrastructure instructions, build up the environment, run the code, specifically, but you're calling that so this is not looking at it, so it's matching the code and matching up the entire is the function, right? And so one of the you're going to get that level really level, Josh has to complete each step down and figure out what you need to exercise and make precise in order to assert that and between different eventually you're trying to get usability out there or to assert identity. We've seen pretty deep dive in how it's thought as far as and where anything that will be developed but in general how the framework is basically wrapped with the infinite and that service through someone else or audit I'm doing exactly this data not subject to the main existing using have the code, but any variations that occur at the level of the environment infrastructure are not down level and down level. For those of you who are like, wow, why are we going so deep into the infrastructure that we want usability and we want cost setting for a chain of operations across the organization? If you ran a certain process, into another one, then into another one, where each of those processes in the chain is used to identify. This is why the most useful analysis the provenance really much building representing all of the things that go into the state and where they came from except before. And that basically as far as here
Oh yeah. Okay. Why is my mouse not? Yes, there is. It's called Cat on GitHub. I can't scroll down. Okay. Yeah, there is a repo. It's called Cats. Right now, it's on Ubuntu 20.04, so you'll have to run in a VM, but it's supposed to be run on a VM. Not necessarily. I have to create I have to port it to Mac. So once I do that, you'll be able to use it. Yeah, and there's documentation. There's demo examples. Show you examples of what I ran. It's in here. Yeah, everything I demoed is in here, so you can just walk through this. Okay. Well, it's like it's a proof of concept. I would say a data scientist can collaborate with, I don't know, a machine learning engineer and an infrastructure engineer on it, or you could do all of that. Like me. You could do all of that.
So you have address it, and you need to have states of the world, and how do you not encode up where it is one track go, or you have to go and that certain public that can have well-known that no site and then you go to the stage that you, for example, even just that data format, that's going to be complicated and type data now recognize as a variable, but you need to approve it because it's actually said you still then you not okay. You make query, who's one of here? Like with another tech like a tool that you are hiring this query that creates a two-step problem from a trusted projection at source to now let's say yeah, this collaborators are to have these on track for associated with traffic and right. Good attention to provide a guarantee that we're online distributed and also clear itself as a company so if you in this case involve the number of as defined by some one data set, you want to make some here, you don't want to. You don't necessarily want to use the data set because you just want to get the service, not to have it as a, it has an identity. make sure that but there's like higher balance. You can't actually do a multi-target if you don't have reproducibility of a file. So this is very much like the but the collaborators that compete over data are building like lower level data that's and the contract revolves around how to build that song to essentially they're doing work that is making it possible to get that. And we're talking about how to align inter-organizational data in this example go from some source data of trust through 2 or 3 distinct processes to the data that you actually want and be able to support the problem, supply chain, at scale, how we talk about this data to legible reduce summary. We actually encountered this problem originally billing again, we understand what they were through. There was really no problem. We asked the claims that we built and so we started to assert the actual problem by sequence data processes, especially when the process is there. Yeah, so then again, how we want to first code and problem data processes local data collection aggregation site and then generate process through the data collected more schedule and then aggregate line and to connect with the all fidelity and sub processes are not actually local data different kinds of get it quality serve run as well as apply change supposed to by national level with much stronger all the caveat that this is reference architecture, reference